Welcome back. Today we're going to talk about the rational zeros test. The rational zero test is testing to see what are the potential zeros. So this label on here would be finding potential rational zeros. An important thing to remember about the rational zeros test: it does not give all the zeros necessarily, and it only tests for the rational ones. So it's potential and rational. So a good thing is not necessarily all zeros, and it's only potential ones. So what you're going to see is we're going to list out a lot of potential rational zeros, and maybe only a couple of them pan out. This is how it works. List potential rational zeros. And this is what it looks like. So factors of constant over factors of lead coefficient. Okay, so this is what it looks like. Let's try it on this one. Potential zeros. Equal. On top, I'm looking at this one. So that would be plus 1 or minus 1. The factors of 1 could be 1 times 1 or negative 1 times negative 1. Another way to write that would be plus or minus 1. On the bottom, we're looking at the coefficient here. So this one's also plus 1 or minus 1. Because it's a 1, it would be 1 times 1 or negative 1 times negative 1. So here we go. On bottom, we have plus or minus 1. If we write this out in terms of what are the possibilities, I could have plus 1 over plus 1, plus 1 over plus 1. I could have plus 1 over minus 1. I could have minus 1 over plus 1, or I could have minus 1 over minus 1. Well, when it comes down to it, what are my possibilities? Positive 1 over positive 1 and negative 1 over negative 1 give me 1, and positive over negative or negative over positive gives me negative 1. So for this one, not negative 3, negative 1. I really only have two potential rational zeros. Okay, so I only have two potential rational zeros. And so what I'm going to do is test potential zeros. So when I test the potential zeros, what are the ways I could do that? Well, if something is a 0, that means that when I put the x value in, I should get 0. I should get 0 when I put it in. And so I'm going to do f of 1, and I'm going to do f of negative 1. And so my function is this: 1 cubed minus 3 times 1 squared plus 1. Down here, f of negative 1 would be negative 1 cubed, and I'm using my original function here, minus 3 times negative 1 squared plus 1. Well, when I evaluate these, I've got 1 minus 3 plus 1. So that would be minus 1, so it's not equal to 0. So that's not a 0. And when I evaluate this one, I've got negative 1 minus 3 plus 1. This is also not equal to 0. Okay? And so what does that mean? Well, that means that there are no rational zeros. Okay? There are no rational zeros, so I can't write them as linear factors. Second part. I've got one that's got some different coefficients. So first I'm going to list my potentials. On top, I've got plus or minus 2 on top, because I could have negative 2 times negative 1, so my other factor is going to be 1 here. Negative 2 times positive 1, or positive 2 times negative 1. Okay, so those are my potential factors on top. On bottom, I'm going to look at my 3 here. So obviously plus or minus 1 and plus or minus 3. When I list out my potentials, here we go. Plus 1 over plus 1. Minus 1 over plus 1. Or I could have minus 1 over minus 1. Or I could have plus 1 over minus 1. And you see there's 4 of those, but really it boils down to either negative 1 or positive 1. I'm going to keep going here. Plus 1 over negative 3. I could have plus 1 over positive 3. I could have negative 1 over 3. I could have negative 1 over negative 3. Let's see, what else? I could have 2 over 1, or I could have negative 2 over negative 1, or negative 2 over 1, or negative 2 or positive 2 over negative 1. And again, notice I've got all these different iterations, but what could it be? This one is negative 1/3, or I could have positive 1/3. Okay, so only 2 of the choices actually pan out as distinct solutions. For this one, I could have negative 2 or negative or positive 2. And my last potential would be this 2 over 3. So I could have 2 over 3, and that could be plus or minus 2 over plus or minus 3. And if we look at the way that it's panned out, really ultimately what happens is I could either have negative 2/3 or positive 2/3. Okay? And so what are my options? To easily list them, I could say plus or minus 1, plus or minus 1/3, plus or minus 2, and plus or minus 2/3. Well, my directions say find the rational zeros. So we are going to do the same thing down here, except I'm going to show you a little different way to do this. In this case, evaluating these fractions might be a little bit challenging. So here's another way we're going to test. And I'm actually going to use synthetic division to test this one because it's going to show me if I have a remainder, then I can see some things about this. Test using synthetic division and the graph. Well, what do I mean? Well, if I'm looking at the graph, I could see some potential zeros on there because what the rational zeros test gives me is this is what's actually possible. But if I look at the graph, I can say, okay, are any of them actually close? And so if I go to graph this, I've got 3x cubed plus 4x squared minus 5x minus 2. All right, so check it out. Look at what I've got. It looks like I've got one kind of here at negative 2. It looks like I've got one here at 1. It looks like I've got one here that might be like a 1/3 maybe. Okay, and so if I go back to this, I could say from graph, I should test these. Now on your other calculator, on your TI calculator, it might not be quite as clear, but if you zoom in a little bit, I could see, you know, it looks like I've got one here maybe at negative 2. I've got one here maybe at positive 1. And so I'm going to test negative 2, I'm going to test positive 1, and then this other one looks kind of like more than or less than 0, but not quite negative 1. What are my rational zeros that could fall underneath that? It would be close to negative 1/3. So these are the ones I'm kind of eyeballing. I want to test those. Well, which one's going to be the easiest to test using synthetic division? If I write out my synthetic division, I don't want to test a fraction if I can avoid it. So I'm actually going to test 1 here. And so as we go to divide this, we're testing 1, synthetic division. I bring down my 3. I multiply 1 times 3, and then I add to get 7. I multiply 1 times 7 to get 2. I multiply 1 times 2 to get 2, and I add to get 0. This means that I have a remainder of 0. If there's a remainder of 0, that means an even division. So what that means is 1 is a 0. So x minus 1, x minus k, is a factor. And so if I look at what this means, I'm going to put a number 3 down here. I'm going to factor out, because it's asking me to find all the rational zeros, right? And so if I know one of the rational zeros, I can create an expression, kind of like we did in the previous video. I can create an expression that's polynomials multiplied together. So f of x equals x minus 1 times what? Well, what's my leftover? If this is x cubed, x squared, x, and then my constant, this is 1 degree less. So this is going to be 3x squared plus 7x plus 2. Well, now I've got x minus 1 as a factor, and I can factor this. And so if I go to factor this, I've got x minus 1. And then I know that this is a quadratic, so it's going to be 2 factors. And if I look at my asterisk method, I've got 6 here, 3 and 3. This would be 7. What multiplies to 6 and adds to 7? It's going to be 1 and 6. So if I reduce this, this would be 1 over 3. So I'm going to have, no, 1 over 2. I'm going to have 3x plus 1 and x plus 2. Well, what does that mean? I just factored that. Those are things I know how to do. I found one of my rational zeros, so I wrote it as a linear factor. And now I've got a factorization. Well, what that means in terms of my zeros is this. X minus 1 equals 0. So therefore, x equals 1. 3x plus 1 is a 0. And so that would be 3x equals minus 1. So x is equal to minus 1/3 is a 0. X plus 2 equals 0. So x equals negative 2 is a 0. These are my zeros right here. Okay, so I wrote my factorization. I found my rational zeros. Up here, the instructions say, find the rational zeros, write them as linear factors. Here they are. These are my linear factors. And how do I know they're linear factors? X minus 1 is a line, 3x plus 1 is a line, x plus 2 is a line, and these are my zeros. Thanks for watching, guys, and we'll see you next time.